Sweet. Good afternoon, everyone, and welcome to Securing Modern Infrastructure with Teleport Workload Identity. I'm Noah Stride, and I'm the lead on workload and machine identity here at Teleport, and I'm joined by Dave, one of our senior product engineers.
Hello.
In today's session, we're talking a little bit about the kind of challenges and motivations behind adopting a workload identity strategy. We'll be diving into what I think a workload identity strategy is, and then we'll be talking a little bit about how Teleport Workload Identity can be used to help you implement a workload identity strategy. We should have a demo.
Yes, we have a demo.
It's pre-recorded, so it's pretty much guaranteed to work.
I don't need to pray to the...
And if we're lucky, there will be a Q&A. So, over to Dave.
Yeah, so why adopt workload identity? What are the challenges you're likely facing today that we think this is going to solve? We're in a really rapidly changing world, and obviously that's been true for a while. This is not news, but I think the scale of what we're doing is growing faster than ever before. The stakes have never been higher, and for me this really hit because last week I got a letter from Change Healthcare informing me that my 9-year-old's healthcare information has been stolen. So I've opened up credit monitoring for him, and like data monitoring, and that just is an example of the cracks showing, right? And as Ev talked about, right, we have these deep layers of infrastructure, and we have to secure them at every layer. It can't just be at the top. It can't just be your network perimeter. It can't just be users to machines. It can't just be CI systems to machines. We need to get down to the application, to the database layer, and really fundamentally, strictly authorize these things. You've got drag right now, most likely, and you want to increase velocity. Engineers spend a lot of time creating and managing secrets rather than engineering, and we'd like to not have you have to do that anymore. You end up with an architecture that's a mishmash of different authentication and authorization systems. You probably have certificates, you probably have JWTs, you probably have API keys, and that ends up slowing you down as well, and we want to simplify all of that. If you don't have things locked down to the workload level, to the application level, you end up having a high trust environment at a certain place, right? And you want to get to a true zero trust environment, to a true trustworthy computing system environment, like Ev was talking about this morning, to de-risk reputational or financial risk, to meet security compliance requirements, right? You've got data that must stay in one region of the world, and you need to make sure that only services in that region are able to get that data. And then I just talked about my next slide. Which is you've got compliance issues, and you want to make sure that those things stay where they are. And, or I don't know how many security checklists I had to check off as a platform engineer where I had to say, yes, we have MTLS, but MTLS is not super easy to just like get going unless you have everything in a single Kubernetes cluster, and we want to solve that for you as well.
Awesome. So what is workload identity? Well, we probably ought to start by talking about that first word, workload. What are we actually trying to do this for? For the purposes of this talk, and perhaps for this space in general, we define a workload to be a running instance of software executing for a specific purpose. Now that's a pretty loose definition, and that's kind of on purpose. I could be talking about an API, a database, a CI/CD pipeline, something ephemeral like that, and much, much more. Now, if you think about the kind of workloads that you have in your environment, you'll probably realize that all of these workloads need to talk to other workloads to actually be useful. In the case of our API workload, it needs to talk to our database workload. To do this, at least securely, we need to have some sort of authentication mechanism in place. And generally in this space, you may have heard this called like machine-to-machine or service-to-service authentication. If we were to think about historically how workload authentication has been handled, at the simplest level, we have just relying on your network perimeters, that super high trust approach. When a workload talks to another workload, no secret, credential, token, whatever is exchanged. It simply trusts that if someone can connect, they should be able to connect and take privileged actions. This is kind of bad. I mean, to kind of go over the point that we've heard many, many times, if an attacker gets past your network perimeters, they can now do anything.
If you're here, hopefully you're not doing this.
Yeah, well. And I think there's sort of this point as well, not only is there that security risk, but from just an understanding what's going on in your system, it's really hard because you can't attribute actions to a specific service or machine. If we were to think about what people are mostly doing today, we have our long-lived shared secrets, whether that's a username and password for a service account, an API token, or something similar. These are typically long-lived, a week, a month, or a year, and you've probably committed to the fact that you're going to rotate these, or perhaps you set out planning to rotate them. If you had actually rotated them on the schedule that you were planning to, how much of your engineering time would have actually been lost to creating and rotating them? And if you were actually rotating them on that weekly or monthly basis, that's still a week or a month that an attacker can use those credentials if exfiltrated to complete further attacks. Now, secrets managers do help a little bit here. They provide a centralized place for you to create and rotate those secrets, or they might even rotate them automatically for you. But now you have a bootstrapping problem. How do your workloads authenticate to the secrets manager in order to get the other secrets? In the space of workload identity, we refer to this problem as solving the bottom turtle. Now, if we were to start to think about a better way, where would we start? Well, I would start by replacing those long-lived shared secrets with a verifiable identity document, a certificate that can encode the identity of the workload and be verified by other workloads. We get a couple advantages immediately from this. First of all, our workloads can now authenticate without revealing anything sensitive. What do I mean by that? If we have like a bearer token, if a workload wants to use it to authenticate, it needs to put that in a HTTP header and send it across the network. Across the network, even if you're using TLS, if there's like a man in the middle or whatever, that can be intercepted and exfiltrated. With certificates, we can leverage public key cryptography. Our workloads can authenticate without having to reveal anything sensitive at all. Now, as I've said, there's still a risk of exfiltration, even if we have that certificate and private key on a host. But if we make these super short-lived, e.g. an hour, we're now in a situation where even if it is exfiltrated, it's much, much harder for an attacker to use. We can further reduce the risk of exfiltration by leveraging things like HSMs or TPMs to secure the private key. By switching to certificate-based authentication, where we've kind of encoded all of the information about the workload's identity into the certificate, we unlock a more semantic form of authorization. If we think about tokens, this might not be true of all cases, you'll be writing a rule to the effect of someone who knows the value of token Y should be able to do X. But if we have all the workload identity information in a certificate, we can write a rule that says something like, the payments processor service in Europe should be able to do X. This same more detailed information can be used for the purposes of auditing. We can attribute actions to a specific pod of the payments processor service, rather than someone who just knows the value of token Y. Now, we need a way for our workloads to actually get that certificate. And we have a bit of a challenge here because we want to make these certificates short-lived. We not only need to provide the certificate when the workload starts, but we need to provide it new ones before the old ones expire. And this makes some of our traditional options, like environment variables or files as a delivery method, a little bit more awkward. Instead, we could deploy an agent close to our workloads, a workload identity agent, on the same host or on the same platform. Our workloads can connect to this agent, request their initial identities, and receive any updates pushed back over to them, solving our rotation and renewal problem. But now we're back to the problem we discussed earlier. We have a bootstrapping problem. How does our workload identity agent know which identities to issue to which workloads, at least without those workloads having some kind of initial secret? Workloads tend to run on platforms in almost all cases, just kind of depends what you define a platform to be. You could be thinking of something like Kubernetes, really advanced, or we could just think about a systemd service running on a boring Linux host. These platforms hold metadata about the workloads running on them. And because our workload identity agent is running on the same platform, it can query this metadata from the platform. It can take something it knows well, like the process ID of the workload that is connected to it, and enrich this, and then use this metadata from the platform to make decisions about what identities to issue, without that workload presenting any kind of secret at all. We've gotten rid of our secret zero, and we tend to call this process workload attestation. Now, everything I've discussed as a hypothetical model at least sounds pretty good, but there's a problem here. If there's no standard, everybody's implementations are going to be a little bit different. And if a workload in organization A can't talk to a workload in organization B, that's kind of pretty awkward in this modern era. This is where the Secure Production Identity Framework for Everyone, or SPIFFE, comes in. SPIFFE is a set of open standards sponsored by the CNCF for implementing workload identity. It not only allows compatibility between workloads running using one implementation and workloads using another implementation, but it also means there's a bunch of off-the-shelf tools and SDKs that will work with any workload identity provider that is SPIFFE compatible. SPIFFE standardizes a couple of things. The first thing it standardizes is the SPIFFE ID. Now, this is a format for encoding a workload's identity. It takes the format of a URI. This alone isn't actually all that useful. You can't just trust someone is who they say they are, at least not when it comes to workload security. So this is where the SPIFFE verifiable identity document, or SVID, comes in. A SVID is a cryptographically signed document that encapsulates that SPIFFE ID, and it will allow other workloads to verify that signature and know more information about the workload talking to them. This comes in two flavors, the X509 SVID and the JWT SVID. Finally, the SPIFFE specification specifies the SPIFFE Workload API, which is the API that should be used by workloads to request their identities from our workload identity agent.
So let's talk about this in the context of Teleport. Teleport workload identity implements all the ideas we've talked about so far. It forms the foundation of a workload identity strategy that you can go out and start using. It is very different from anything we've released before in Teleport, though, because I'm sure some of you in the audience are thinking, wait, I don't want every single piece of traffic between every single workload that I have, service, database, job processor, whatever, flowing through the Teleport proxy. That feels like it would not scale. And the answer is, this does not flow through the Teleport proxy. What we do here is we provide the documents, and how you use them is up to you. So you can go put this in a microservice and in front of a database, and they can talk to each other. We'll talk about a little bit. You can use it to identify a job running outside of AWS to AWS as with an IAM role. There are lots of implementations, but where we act is as the identity provider, and then you get to you can use this flexibly in your architecture however you need to. Now that is also very broad, and we are forming opinions about the best way to do this with people, so we'd love to talk to you about that as well. It's also already available as part of any existing Teleport cluster running 15.2 and later, and it's compatible with the SPIFFE standard, and we'll talk about the advantages of that in a little bit. Just a real quick overview for the technical folks on what the architecture is here. So you have your Teleport auth server. TBOT, which is the existing machine ID binary, is what the agent is that's running on Node or next to your workloads. We'll look at some of those options in a moment. It opens up the workload API over a socket, and workloads running on that node are able to request SVIDs from TBOT. The SVID document is provided, and then that workload can use it to engage in MTLS communication that is authenticated really strictly with other workloads, with databases, or with cloud IAM providers. I mentioned AWS IAM roles anywhere, but GCP and Azure, if they haven't already shipped, are coming with similar things soon. So let's look at a quick demo. If you saw my performance this morning, the encore is probably not quite as good. But basically here, we're going to look at a web application that is protected by Teleport app access. And we're going to open up an application here that is a live view of the system using workload identity here. So we have a node that is, or that has a couple of services running on it. One is a front end here at the top, written in Node. And Node actually doesn't have a great SPIFFE library right now, but because we're SPIFFE compatible, we can rely on the community, in this case, a proxy called Ghost Tunnel that is SPIFFE compatible, that can run in client or server mode. Here it's running in client mode, so the communication between the app at the top and the proxy is just local over HTTP. But the proxy itself is getting a SVID from TBOT that's running as a process on that same VM. That TBOT, via a role, it's all controlled via the standard Teleport RBAC, is allowed to issue SVIDs for workload ID demo/demo web, and it will only issue those SVIDs to processes running on this node using user and group ID 3002. So there's our node attestation to TBOT, and then TBOT is performing workload attestation down to that workload via Linux metadata. That front end is speaking to a Go-based backend that's running both on VM and Kubernetes. This is demo backend 1 and demo backend 2. For demo backend 1, the architecture is basically exactly the same, except we don't need the proxy now because Go has an excellent Go SPIFFE SDK that we're going to look at the end of this video that's super easy to drop in, as most of the SDKs are. That one will only allow processes running as user and group ID 3000 to receive the SPID demo backend 1. In Kubernetes, we're using Kubernetes metadata. So it will only provide this to a pod using the service account demo backend 2 running in the workload ID demo namespace. You can expand that out. You can have other labels, right? There's a lot more you can do in Kubernetes than you can do on a Linux VM. And the critical thing here is, again, they have very specific SPIDs that they're authorized to speak to, which we'll look at in a sec. These are bots that are registered in your bots page inside of Teleport. It's very easy to go and check out the metadata on them. It was hard timing the speech to the recorded thing, which was I was hoping I could scrub. And again, this is all controlled by roles. So this is the role for the demo web tbot that is issuing that SPID. You can set it via what paths it's allowed to issue, for what DNS and IP SANs. Here I've got very open ones, but I'm highlighting it just to show that you can restrict those more if you would like to do that. And again, this is an array, so you can do this for multiple paths if you were doing it, if you had, say, 10 or 15 different processes running on a VM or multiple pods that you wanted something, a container to be able to issue. And this is similar over in, so this is the actual tbot config. And I'm using Terraform here because one of the things I wanted to highlight, people have asked, well, how do you do this at scale? And the answer is, this is a Cloud Init script that I can drop onto any VM as I'm standing it up. I can template in workload and group IDs, the paths that I want to be allowed to, that it should be issuing. And one of the great things about this design that Noah came up with is that you don't end up with some database that's holding 50,000 rules about what can be issued and where. We're pushing that configuration out to the edge, so it's really highly performant and doesn't hit a lot of scale issues. This is the same thing in Kubernetes. This is a config map that I've created with Terraform that's going in for the daemon set that tbot is running as out on every node where it can provide SPIDs to the appropriate pods. Click over, Dave. Click over. And again, just namespace and service account there. Clearly had a lot more to say when I was recording the video here. Shin, where are some of those jokes that you had?
I'm out.
Oh no, oh no.
Is that just the end?
No, it's going. I just had I think I was speaking a lot more over this one. Like I said, I've been scrubbing when we've been practicing this. What did the fish say? Okay, so what we're going to look at now is what it actually looks like if you needed to make code changes, if you were not using something like Ghost Tunnel Proxy to do this. So this is the Go code for those backend services. You can see I'm importing 3 things from the Go SPIFFE SDK. And then this is the really killer feature for me here, is that all of the code that you need to modify is here basically between line 45 and line 53. So I'm setting up a source, which is the workload API I want to speak to, handling error if it comes up. I am pulling in a client ID from my configuration, and I'm creating a TLS config. And if you see over here on the right, it says authorize ID, which I'm going to use to just do one, but I can change it to authorize one of, where I can pass it a list. So I can handle my authorization rules here. And then that TLS config is just passed to a regular Go HTTP server. I don't have to change the architecture or construction of my application. I just need to go get the SPID from the workload API and pass it in as my TLS config. So it fits in, and that's true for Java, it's true for Rust, Python, everything where there's a good API or SDK. So now we're gonna break it just to show this off. So this is going into the systemd service for demo backend 1, and we're taking this backend approved client SPIFFE ID, and we're gonna change it from demo web to demo app. So again, demo web is still sending the SPID for demo web, but demo backend 1 now will only accept traffic from demo app. I'm going to refresh the page, and the backend is no longer responding because we're no longer authorized to speak to that backend. And again, this comes back to Noah's thing of the EU payment server, right? So this is a kind of simplistic representation, but you can extrapolate this out to I only want this particular pod to speak to this database. I only want this particular set of VMs to be able to speak to that particular set of VMs. You have such strong identification of your workloads that you can write really profound authorization systems around it. So this is all in code. This is in a public repository. I'm going to leave this slide up for 5 or 10 seconds here because there's nothing more frustrating to me than I'm like, oh, I want to look at that code, and then it's in tiny little font at the bottom left of the slide, and I can't actually get it. So there's a person taking a picture. Please take a picture if you'd like. You can check this all out. You can look at the Terraform code. You can see how it's all stood up. You can reach out to me. It's definitely meant to be readable. With a little tweaking, it can be reusable. If you want to actually try it, reach out to me in the community Slack or something. Everyone's got their picture. Okay, cool.
Sweet. So now that we've talked a little bit about what it is and a little bit about how it works, let's talk about why this is actually worth doing, right? So first of all, the headline thing, right? We're giving you the tools to replace those long-lived shared secrets. And the benefit here is really twofold. Not only are you reducing the liability or the risk of the exfiltration of those secrets, but you're also saving your engineers time. A study estimated that for each service or component you have that uses secrets or needs secrets, you'll spend about 3 engineering hours a year rotating and creating them. And this quickly adds up. If you've got 200 services and you're paying your engineers $180 an hour, then you're going to save $108,000 worth of productivity value. And your engineers will thank you. It's not fun creating and rotating secrets. Now, not only are you saving your engineers time, but you'll be increasing their efficiency. They'll waste less time gluing together incompatible workload authentication solutions. And more importantly, you're creating a golden path that simplifies architectural decisions. Now, what do I mean by that? When it comes time for your engineers to create a new service or add a new feature, they'll already know how that workload is going to be able to authenticate to other workloads securely. You've given them a framework. They can focus on building the feature that actually matters to your customer rather than solving a problem that's been solved 1,000 times before. It's also giving you the tools to meet the compliance requirements of today and tomorrow. With X509 certificates easily issued, you can implement that zero trust or MTLS you need. And with the power of this more semantic authorization, you can create those rules we were talking about to stop perhaps sensitive services in Europe talking and sending data to services in the States. Now, why choose Teleport as the foundation of your workload identity strategy? There's a couple points here, but the 2 main ones for me. First of all, if you already operate Teleport, you already know Teleport, and you probably do if you're in this room, then that's going to let you focus on the workload identity part of your implementation. You don't need to learn how to operate and deploy something new because you've already got that internal knowledge in your organization around how Teleport works. Second of all, by choosing Teleport, you'll be able to leverage our knowledge and experience when it comes to workload identity, cutting down the time it will take you to ship your implementation. And finally, at the end of the day, if something does go wrong, you can lean on us for support, something that you can't necessarily expect from a free and open source solution off of the shelf.
So how can you use it today? Once you are starting to do this, and maybe you pick a small subset of services that don't have 1,000 many-to-many relationships, but you're going to say, I want to try this with this subset of my workloads, you can directly implement the SPIFFE SDKs into your code, as we saw, with pretty minimal code change, or by using and leveraging something like an integration with a service mesh. Istio and Linkerd both have SPIFFE compatibility. We have things like Envoy that has SPIFFE compatibility now, and Ghost Tunnel, where if you have older workloads that no one wants to touch that code because we're really not sure what pillars would fall over, you can just stick a proxy next to it. We also have compatible third-party APIs. Like I mentioned earlier, AWS rolls anywhere. GCP and Azure have similar things. And the core thing here is SPIFFE is the protocol that everyone's adopting. And while this is pretty cutting edge, this is the direction it's going. And so once you have things that are SPIFFE compatible, more and more ways to open up and communicate and federate are going to come along. And that's really what we'd like you to go do. It's go try it. It's there. As much as we're looking for design partners right now, this is a thing you can go try. And we'd love to see how you're trying to use it. We'd love to know what challenges come up. And as you go through that experience, please reach out to Noah or me. And we'd love to talk to you about how it's going for you.
Awesome. Thank you very much, guys. We have about 5 minutes for questions. You can also clap now if you want. Perfect.
Thank you.
questions from the audience, you'll have to shout because we don't have a mic. Oh, we do have a mic. But do we have someone to hold the mic?
It looks like Kenny's doing it.
Oh.
Yes.
Don't come to me when it doesn't work.
So come to me and then I'll...
Yeah, so question for you, Noah, I think, and for you, Dave, as well. So when we talk to customers, they like this, right? But many of them ask a question, well, where do I start? Because they have thousands or hundreds of thousands, actually, of endpoints, microservices, databases, CI/CD systems. What is the criteria? What are maybe some of the starting points? Maybe the advice. Where have you seen customers being successful without naming them? Right? Like what would be your advice to them with adoption of Teleport's version of SPIFFE or just in general SPIFFE?
So I definitely think it's tempting to look at this as a massive transformational thing, right? Use it between all of your workloads everywhere. But as you've quite rightly pointed out, that's not, you can't just do that overnight. That's probably, if your organization's large, a 5 or 6 year plan. But it's very easy to start picking out the things that are, one, easier to achieve and probably lower impact as well out at the edges. So one of the customers we're working with, they want to use it for communicating between their workloads and AWS. Right now, they've got some long-lived static credentials there. They've identified that those are high risk to them because those credentials give access to sensitive S3 buckets. And they want something that they can drop in to have nice short-lived certificates and then authenticate off to AWS using AWS roles anywhere. And that's quite a nice place to start because, yeah, it's off at the edge. They don't actually have to do one half the implementation because AWS has already done it. And for them, it's fairly easy to drop it in, try it out on a couple things, and start learning about how they're going to roll out workload identity further into their environment. And I think it's going to be a learning journey for a lot of people. Workload identity is fairly new. SPIFFE's only been around sort of 4 or 5 years, and more people are picking it up. And I do think that starting off with a little bit off in the corner is great because you start to learn the tech, understand the tech, and have those foundations for, hey, how am I going to roll this out everywhere?
For MTLS to work with the certificates, things like an L7 or L4 load balancer that's doing SSL inspection, do you guys foresee any sharp edges that are going to make large enterprises really difficult to migrate over to this when that infrastructure is already in place?
So that is a really interesting point. I think that is, of the 2 types of SVIDs, you've got your X509 SVIDs and your JWT SVIDs. And the X509 SVIDs are great when you've got kind of that easy connectivity story between your 2 services, but quite rightly, if you have a layer 7 load balancer that's exposing its own TLS certificate or something, that's going to cause you problems. And it's in those cases where something like the JWT SVID or kind of the upcoming lightweight SVIDs that they've specified are kind of a much more interesting option. But I do think that there's some interesting things there. It's like, okay, well, what if rather than what if the client is not expecting to see the SVID of the workload it's talking to, but expecting to see the SVID of the load balancer it's reaching? I think there's a couple different options there in terms of how you tighten that up. But I think from that point onwards then, right, your layer 7 load balancer can pass that information forward on the client's TLS certificate. That's something pretty fairly out of the box on Envoy or on other tools like Ghost Tunnel. But it is, yeah, I think there is, X509 certificates aren't the answer to every problem. And that's where stuff like the JWT SVIDs and the lightweight SVIDs are going to be kind of that alternative option. Cool, and we are out of time.
All right, well, please come ask us more questions after.